Today we're going to talk about the Azure Container Service Virtual Nodes add-on, which allows you to scale your Linux workloads into the Azure Container Instances service. Azure Container Instances, hereafter called ACI, runs containers in a serverless manner, where they are charged per second of execution time rather than for the node they would be running on. This allows for faster bursting of workloads to meet demand and more flexibility in your node pool sizes. Let's start by building our demo environment. First, we'll create a resource group, then create a managed identity for AKS to use when accessing Azure resources like our virtual network. Virtual nodes require Azure CNI networking, so let's build a VNet to use, followed by adding one subnet for the AKS cluster and another for ACI to use for virtual node pods. We'll then need to give our managed identity access to the virtual network so that AKS can use it. At this point, we're deploying our AKS cluster using the following command. As you can see, we've passed the command line options to enable virtual nodes at cluster creation. This command adds and configures the add-on at cluster creation using the enable add-on and ACI subnet name flags. But we could also use the AKS enable add-ons command to enable virtual nodes on an existing cluster. Now that our cluster is deployed, let's look at the nodes in it. As you can see, there are two nodes in this cluster, a small Linux node and the virtual node ACI Linux node, which is implemented using virtual kubelet. This virtual node is tainted by default, so only workloads that specifically tolerate that taint will run in ACI. There's also an additional pod in kubesystem, the ACI connector. This pod handles communication between our AKS cluster and the Azure Container Instances Management APIs. Let's take a look at the deployment we'll be using today. This is a very simple Nginx deployment with a few added wrinkles. First, you can see the toleration for the virtual node taint, which will allow these pods to schedule to the virtual node. Below that, you can see a node affinity section, which prefers nodes that do not have the type virtual kubelet. This causes the scheduler to prefer to place your pods into existing nodes if resources are available, rather than running them on ACI. As you can see now that we've applied our deployment, we have one replica running and it's on our cluster node. If I scale the deployment to 2 replicas, a second pod is scheduled, and because we have room on our node, it runs in the cluster as expected. However, this node is now fully allocated, so if I scale the deployment to 10 replicas, we'll see 8 new pods appear and schedule into ACI. When these pods are scheduled, the ACI connector pod that we saw in kubesystem submits API requests to create container instances inside the cluster's managed resource group, where the other AKS managed resources are. As you can see, these pods are all visible in the portal, and you can view their configuration and logs here, as well as via the standard Kubernetes methods like kubecontrol. As we bring this demo to a close, let's scale the deployment back down. As expected, when I scale to 2 replicas, the affinity section in the deployment causes Kubernetes to retain the 2 pods that are running in the cluster and delete the pods that are running in ACI. Thank you for your time. If you have any further questions, you can find our documentation on virtual nodes at aka.ms/aks/virtualnode.